All right, welcome back. Today's lesson is on partial fraction decomposition. That's quite a mouthful there. I want us to go back to a section that we've already done and recall how to add a couple of fractions, as crazy as they are. The common denominator in this case is going to be x plus 2 times x minus 4. And to change that to be the common denominator, I'm missing an x minus 4. And here I'm missing an x plus 2. And what that's going to give us is this fraction here. And up top, I'm going to distribute and combine. And that gives us 10x plus 2. So what have we accomplished? Well, not a whole lot, but the whole point of this is we know how to go from here to here. We just did that. We're now going to learn how to go from here to here, meaning a more complicated rational expression to a couple of less complicated rational expressions. The reason that we would even want to think of doing something like this is because doing calculus to this is awful. Doing calculus to this is one step, one each. Very easy to do. So we want a method of reversing this process. So partial fraction decomposition is a method of breaking a complicated rational expression into the sum of simpler ones. First, we're going to factor the denominator of the rational expressions. And then we're going to move on from there. And there are three types that we're going to need to be concerned about. Distinct linear factors, that's like this one. These are distinct linear factors. Repeated linear factors, this would be a repeated if it was x plus 2 squared or to the third power, then it's repeated. A non-factorable quadratic, a common example of that would be something like this. Something that is impossible to factor as far as the real numbers go. All right, so we're going to start with the distinct linear factors. That's our first one there. And what we're going to do, so let's say we have something like this. This is what we just worked out. We're going to assume that we can break this down into something over x plus 2 plus something over x minus 4. So what we do is we multiply through by, let's use the green. Something like that. And when I multiply here, that denominator is gone. So I'm just left with this. Here, the x plus 2 is gone. I'm left with a times the x minus 4, and b times the x plus 2. Distribute and break it down so that I take the x terms, factor an x out, and the non-x terms, and group them together. And here's the point. That must equal that, and we can see that here. And that must match that, which is where we are there. Now we have a system of equations, and when we solve the system using either the elimination method or substitution, doesn't matter, we get a is 3 and b is 7. And you can see that's where we started. So we went from here to here. So let's do our own example. And first thing we need to do is completely factor the denominator. I can pull an x out and I can factor it into 2x minus 1, x plus 2. And we are going to go on the assumption that this can get broken down into a over x plus b over 2x minus 1 plus c over x plus 2. Now this is going to get messy. So I'm actually going to start way up here. So if I multiply both sides by the LCD, I get, I'm going to go way up here. I get x squared plus 2x minus 1 equals a times 2x minus 1, x plus 2, plus bx, x plus 2, plus cx times x, 2x minus 1. And if we FOIL all of that and distribute, we get this. We get 2ax squared plus 3ax minus 2a plus bx squared plus 2bx plus 2cx squared minus cx. And rearranging it, we get x squared plus 2x minus 1 equals minus 2a. And so we end up with this system here. And negative 1. Very clearly, we can see right away that a is 1/2. And that's going to give us, plugging that in, we're going to get that b is 1/5 and c is negative 1/10. So we get here that our original expression is going to be 1/2 over x plus 1/5 over 2x minus 1 minus 1/10 over x plus 2. So I did skip a step or two to fit in the space and to get the algebra down, but you can go through and fill in the blanks and definitely work that out. All right. Our other options is what if we have a repeated linear factor? Well, here's the thing. We are going to assume, in fact, let me write this. If I say that I want to add that, or I wanted to add this, the LCD is the same. It's still x minus 5 squared times x plus 3. So whether I have this term or I don't have this term, the LCD is the same. So when I'm given the result like this, I'm going to assume that I have that one there. If this one doesn't exist, like it doesn't up here, then that, whatever that letter is, that will equal 0, and it'll just go away, and it'll become like this one. So we are going to assume that we have this intermittent one. Even though we may not. And I'm going to multiply through by the LCD to get x minus 3 equals a times x plus 1 squared plus b times x plus 2, x plus 1, plus c times x plus 2. We're going to FOIL that. Now 2ax plus a plus bx squared plus 3bx plus 2b plus cx plus 2c. And what we're going to do is we're going to gather our x squared terms together to get a plus b times x squared. And now we're going to gather our x terms. So 2a plus 3b plus c. And then our non-x terms, that's going to be a plus 2b plus 2c, which gives us our system of equations. So this is like 0x squared in front here. So a plus b is 0. 2a plus 3b plus c is going to be 1. That's the coefficient there, the 1 there. And then a plus 2b plus 2c is going to equal the -3. And I'm going to let you, I'm not going to waste time or space here working this out. When we solve this system, we get that a is -5, b is 5, and c is -4. So what we end up with is -5 over x plus 2 plus 5 over x plus 1 minus 4 over x plus 1 squared. Didn't mean to cut through that. Hopefully you can easily see that. Now we got a couple more. What if we have non-factorable quadratics? Well, let's take this first one here. We have 2 over x minus 1, x squared plus x plus 1. And when we have a non-factorable quadratic, we're going to end up with, because it's a quadratic, we need to end up with a linear, potential linear above it. And now I'm going to multiply through by the LCD again. And you can see that quadratic does not factor. And when I distribute and combine, I end up with this here. Which means a plus b equals 0. A minus b plus c equals 0. And a minus c equals 2. And solving the system, again, you can take some time to solve this. We end up with a is 2/3, b is -2/3, and c is -4/3. So what that tells us is that 2 over x minus 1, x squared plus x plus 1, equals 2/3 over x minus 1 plus -2/3 x minus 4/3 over x squared plus x plus 1. So there you have it. Cool stuff.